Right, let's have a look at the second example that we're dealing with today. Right, again, this is April 2023, the latest exam paper. And this one was 5 marks. I'm surprised that this is more than the other one. The one that I just did previously, that should have been like 7 marks or something. Okay, but let's have a look at what we're dealing with here. Now, we have to just substitute values, but first we need to determine how to integrate this. Now, there's two different ways you can approach this example. Option number one is you could let u equal to 1 plus sec squared. Right, that's one option. The other option, you could let u just equal to sec x in the denominator. Because what are you noticing? The derivative of sec is sec tan. So you could have been thinking along these lines. Okay, let's have a look at the difference. Right, so here, if I find du over dx, what is the derivative now? The derivative of 1, 0. The derivative of sec squared. In order to differentiate sec squared, remember, this is actually 1 plus sec x in brackets all squared. So therefore, in order to differentiate this, I need to use the chain rule. You're clear with that? I need to use a chain rule because I have a power which is a number. So now, the chain, first of all, the derivative of 1 here is 0. Then 1 times 2 will be 2 sec x, and then the derivative of sec x will be sec x tan x. Now, let's see if this is going to work. Let's see if it's going to work if we try it out this way. So now what will happen here is I'll end up with 2 sec to the power 3 times tan x. Now, can you see that? Now, let's see what happens here. So now if I make dx the subject of the formula, then that's going to be du divided by 2 sec cube x times tan x. And clearly now, if you do this, do you think everything is going to cancel that? Let's see. Let's see. Right. So now what will happen here? You end up with your pi over 4, your 0 there. This is u. And then you've got sec x tan x there. And then you've got du all divided by sec 2 sec cube tan x. What happens? What happens now? So here I end up with the integral. I've got pi over 4, 0. Right, so now here I've got this 1 over 2. Let me remove this limits here for now. Okay, let me just remove the limits. We're dealing with just the integration here. So there's my 1 over 2. Tan and tan cancel nicely. You can see that. Right, tan and tan cancel nicely. But the problem here is sec will cancel here. So you end up with just 1 over u times what? Times sec squared x. And this is du. Okay. Now, right now, we've got a problem here. The problem is we cannot have any variable x after we introduce our u-substitution. The variable x needs to be eliminated from this problem. So now we get stuck now. Alright. So now let's see if we can make it work. Let's check. So we've got sec squared. Now I know that from my original substitution, u is equal to 1 plus sec squared. Can you see that? So therefore, u minus 1 will equal to sec squared. Yes. Where about?
Yeah, we did the chain rule. Because it's your f of x equals to n power, you got the power.
Yes.
Then f of x in the bracket.
Oh, sorry. Yes.
Sec tan.
Sorry, my mistake there.
So you got stuff to this.
Oh, that's why. Yes. That is why. And now, to correct it, okay, let me just correct it quickly here. I need to redo now. Right, sorry, the derivative of sec is sec times tan, so that's going to be sec squared. Yes. So now, this will be a sec squared, and this will be a sec squared also. So now, we're just going to have sec here. Now we've got a problem, as I was saying. U minus 1 is equal to sec squared, so u minus 1, the square root of u minus 1 will equal to sec x, and it's going to be a problem here. Okay, it's going to be a problem, so that's going to be u sec x, which is the square root of u minus 1, and now we're stuck with another problem here. Not working, can you see that? It doesn't work. So, what to do? Are we now going to try something else out here? Can't be. We're not going to do that now because there's no exact derivatives here as it is. So now, what happens if you let u equal to sec x? Now, du over dx, the derivative of sec x will be sec x tan x. Now, dx is going to equal to du divided by sec x tan x. So now, here, that's going to be my sec x tan x all over 1 plus, what is sec x? It's u, there's my u here, all squared. I can even replace this sec x with u also.
That's sec squared. Just we sec u minus 1 is sec.
Sorry, your question is?
See there you change it to this.
We're talking about this one?
Yeah.
Okay.
And then you put there u minus 1 is equal to sec squared. Now let the sec squared change.
Oh, there's it here. U is equal to 1 plus sec squared.
Oh,
U minus 1 is equal to sec squared. Now this was just, I was just trying to make it work here. I corrected my error there. So now u minus 1 is equal to, I'm looking at this one. Okay, you're clear with that now? So then I have sec squared is equal to u minus 1, but there is no sec squared here because the sec and the sec cancelled over there, so I end up with just sec. We got a problem and there's it. We get stuck here. Alright, so just going back here now to where I was. So I've got sec x tan x here, and then I've got dx is equal to du divided by sec x tan x. So that's du divided by sec x tan x. If you want to, this can be u and u also, but it will cancel. Alright, so now this one works out nicely now, you can see that. So now I end up with 1 over 1 plus u squared du. Now, how do we integrate 1 over 1 plus u squared? So now this goes to your trig substitution. There's no exact derivative here. You see that? So here, this will be 1 over a squared plus x squared dx. You have to go to your formula sheet for this one here. Okay, you go to your formula sheet and this will equal to 1 over a inverse tan x over a plus c. So in this case, I have 1, and that's 1 squared plus u squared du. So it's just that it's not x now, it's the variable u here. Can you see that? So now this is going to equal to 1 over 1 inverse tan u over 1 plus c, but I'm not putting down plus c now. Right? So I need to substitute my values. So I'm not changing the limits here. So I'm going to substitute back. Basically, problem is solved now. Can you see that? The problem is solved. So this is equal to inverse tan of u. What was u? It was sec x. And now I need to substitute my pi over 4 and 0. So, but still, this is, compared to the previous example, the integration by parts example, this one is much more easier, but you need to make the correct choice here. Can you see that? Right, so anyway, let's do the substitution on the calculator there quickly. Calculator in radians. Calculator must be in radians here, not in degrees. Okay, calculator in radians. Let's see what we get. Give me that calculator there quickly. So convert it to radians. So we're going inverse tan of. Now, there's no sec on the calculator, so when you're doing this on the calculator, you have to change it to 1 over cos. You're clear with that? Because there's no sec on the calculator, so that's pi over 4, 0. So that's 1 divided by cos of x. And we are substituting pi over 4. So I get 0.95531666181. Substitute the 0 and you get 1 over 4 pi. You're getting that on the calculator? So substitute first was my pi over 4. I've got that minus 1 over 4 pi. So final answer is 0.16991845547. Anybody did this? Do it on the use the integration function on your calculator, and let's verify the solution. But when you're typing this out, you'll have to type out sec as 1 over cos, and type out the sec squared as maybe 1 over tan squared, and we'll check it out. So 0.17. That was that.